right, thank you so much. It's so good to be back. This is my third time speaking at Nordic APIs, and this is a lot of fun, so thanks for having me. My name is Andrew Carlson. I'm the CTO at Grapple. We build a DIY data visualization platform. So think Looker or Tableau, but if you don't have a data warehouse already, and you need some, like there's some teams in an organization that need to service that. So that's what I'm working on these days. It's a lot of fun. And what we're going to talk about today is API orchestration a little bit more broadly. And this is really interesting even more recently with the recent discussions around MCP and how MCP as a pattern can kind of act as an orchestration layer as well. But there are some additional really interesting ways that we can do this that are a little bit more deterministic that we can apply to our applications today. So we're going to talk about how responsibility shifts when API orchestration is like a solved problem, because in some ways it kind of is. So let's start by building an application. So we're going to build an app that lets users register and help them plan for Platform Summit. So to do that, first we need a UI. Very simple, right? We'll just throw some React in there, and we can let Lovable go ahead and code that for us. We do have a few different data sources that we're going to be integrating with, right? We have information about speakers, attendees, talks, schedules. Maybe these are different tables, and these are just the ones that we have on our side of the application. There are, of course, external databases or external persistent stores that we'd want to integrate as well. Now, since we are vibe coding the heck out of this app, we're just going to go ahead and connect directly to Supabase and we're just going to shove all our information right across the wire, right? This is a real thing. This was a vulnerability that was exposed. Basically, a bunch of people were doing this in Lovable, and they were wiring up their client directly to their Postgres databases. So this is an API conference. We're not going to do that. Instead, we're going to actually develop some APIs for this. Now, in this case, we might have 4, just as an example, but you can imagine quite a few more, right? We have APIs for authorization and for registration for the conference itself, right? We need users, but then they need to register. They need to know information about things like schedules, and then, the different talks that are available, and then maybe create a custom schedule so that they can walk through and join each of the individual different tracks. But the reality is, behind these larger domain contexts, we have a dozen or more discrete endpoints. Maybe we need to do registration, we need to log in, log out, the whole checkout flow. You can imagine like cart, checkout, refund, etc. And then we're creating new plans, we're creating tracks, we're submitting talks, things like that. So across all of these different endpoints, we have a bit of a problem. And that problem is all around API orchestration. And I kind of want to sit on this for a minute and talk about all of the things that go into API orchestration. Because if we look at all of these different endpoints and we think about all of the requirements that go into wiring up a client to use these discrete endpoints for our user-facing application, I mean, there are a lot of different things that go into this. And I describe these typically as non-functional requirements because they are usually things like caching, et cetera. But it goes a little bit deeper than that. Like if you think of all the ilities, you'd probably put those in this list. I just have 12 listed here, but we can think about things like authorization and authentication. But then maybe even more complex things like retries. Like what's the retry policy for specific API requests that might fail, might succeed? Parallelization. Are there some requests that we can make in parallel to others throughout the experience so that maybe the experience feels a little bit more snappy or a little bit more natural to users? All of these individual discrete ilities or discrete operations within our API platform, these are all parts of a larger topic, which is just like API orchestration in general. And this is an interesting topic because this is really just complexity that we've been operationalizing within our applications for years and years and years. And where we manage this complexity, it really swings on a bit of a pendulum. And this pendulum it alternates. I have three very simple examples here at the bottom. You can see client server database, and this is as simple as it can possibly be. You can imagine the pendulum hitting a few points in between those as well. But if we think about over time, just how this pendulum and this management of the complexity of all of these different operations that are encoded within API orchestration, where we've managed this. We manage it across this pendulum here. So you can think about early desktop apps and some desktop apps still today. We manage that completely on the client. You have maybe for example, like you have a SQL server or a SQLite database directly within your client application, deploy it to a bunch of end user devices, and then there you have it. It's not necessarily making API calls. All of that complexity happens directly on the server. You're still using APIs, but you're using desktop APIs instead of traditional services. And then on like the far other side of that spectrum, you might have an access application. So there are a lot of organizations, even still today, that operate much of their business on effectively a database that has a very, very, very thin GUI on top of it. And this is an example where you'd have a lot of that complexity managed directly within that access application. More popular a while ago, but we still see some of these today when we're integrating their data into Grapple. And then maybe somewhere in the middle. So we have Web 1.0, where we started seeing that shift away from, okay, we don't maybe operate all of that logic, we don't encode all of that complexity in the database itself. Now we're going to encode some of that complexity in the server. So this can be, you can think of this, the Web 1.0 shift maybe 15 years ago now, where a lot of the complexity for where does the logic lie for retries and authorization and everything else, that was happening a little bit more on the server, and we'd ship an entire, a fully baked page to the browser. And then the next step there, in the timeline is the pendulum swung back to the client. And this is more on the mobile side. So we had the desktop apps where everything was bundled directly onto the individual PCs or Macs or whatever else. And then in the mobile age, we saw something similar. And a lot of the phones that we have today, or a lot of the apps on our phones today, they have evolved to use APIs discretely now, like web services. But for some period, and even some today, we still see a lot of applications that are baking all of that logic directly into the client. Another thing, I didn't include this one, but another just kind of like reference point here is mobile and Web 2.0 are kind of interchangeable. Like you can think of the rise of like single page applications or SPAs as a re-encoding of all that complexity on the client. I know many of you have probably seen something similar, but there were a few clients that I worked on in the past where we were integrating 60 or so APIs, there was a large automotive company that I was working for. We were encoding a tremendous amount of API complexity directly on the client. We were building this application for managing parking across the United States, and so you needed to identify the car, you needed to identify parking spots, you needed to set up a map, add payment processor, and all of that complexity for orchestrating across those different API requests was all bundled directly into the client or the browser. And that was, again, sort of around the time of SPAs. More recently, like you can kind of see that pendulum swinging back towards Web 2.0. I did include SPAs. Well, there we go. Anyway, as is the case with most pendulums, I do think that this is going to fall somewhere in the center of the diagram. And so one thing that I think is really interesting is that API complexity and managing the complexity around orchestration has traditionally been a very, very difficult part of the development process. There is obviously logic that is built directly into the APIs. They're the functional components that are driving the applications that we build today. But one of the most complex parts of building and operationalizing an API platform has traditionally been all of the ilities that kind of surround the operations. So retries, parallelization, caching, etc. And one thing that we've seen recently is that this has been the hard part for a very long time, but it's getting easier and easier. And there are a couple new ways, and a couple that we'll walk through in a demo here in a minute, that this has become easier, and I think will continue to be. So one thing to note is that at Grapple, we integrate significantly more than 60 APIs. We might integrate 60 APIs per customer or something like that. API integration and orchestration is a huge part of the business for us. And I think it was in Postman's 2024, it might have been 2023 State of the APIs report. They made a note basically that the average company integrates about 60 sources or about 60 APIs. And like I said, we integrate significantly more. So what we do here, and I'll walk through a little demo in a minute, but essentially, customers can go in and they can add any of their own data sources, and we're doing a transaction. We're doing some ELT behind the scenes, and we're integrating with all of those discrete APIs. And I really think that there are two emerging and very interesting ways of operationalizing this API orchestration and almost commoditizing it in a way that makes it easy to focus on some other things. The first is for transactional workloads. So with transactional workloads, one really interesting emerging option for this is Apollo connectors. So I think that this is particularly interesting. I have a big warning that you're probably already paying attention to on this screen. But I do think that Apollo connectors is a very, very interesting and emerging way of managing this API orchestration, because it's really useful for the transactional workloads when you're doing a lot of reads and writes. And when you're dealing with internal and external sources. So imagine that you have, for example, APIs internally that you want to consume and externally, and then you want to maybe join some of that data together and then operate on it. This is really interesting, and we'll walk into a code sample in a second, but the biggest warning here is there is GraphQL involved. I know that for some, maybe even many, that is kind of like a bad word, but I strongly encourage you to join the GraphQL track in this very room in a couple hours, and we'll talk even more about it. But the really cool thing about using Apollo connectors is that you can connect discrete APIs in a declarative way and actually orchestrate across them without writing any code. So this is an example of a mapping to a Stripe API for the sessions checkout post. And in this example, you can see we're providing a little bit of the body, we're providing the mode, line items, etc. But the really interesting thing about this is that, like I said, it is GraphQL, but you can do this completely declaratively without writing anything like a subgraph resolver or anything like that. So this is a really interesting way of managing transactional workloads. And then on the other side of that, on the analytical workload side, we have solutions like Airbyte. Airbyte is a really interesting product. It's open source, and they have a really interesting ELT or ETL process depending on the flow that you're kind of following. And this is tremendously useful when you have a lot of external APIs to integrate. Now, this is the demo that we'll walk through in just a minute here, and it's really interesting for specifically like this defined but unknown data. So with the transactional workloads with Apollo connectors, it's really tremendously useful when you're thinking about like the functional requirements of your application, but you have both structured and defined and known data, and that's a little different because you're dealing with things like writes and posts and etc. But with Airbyte, if you just have a lot of data that you're trying to pull in and do so consistently and then orchestrate across those APIs, that's where a really interesting solution like Airbyte comes in. And this one is I think attractive in a way that other ETL and ELT products maybe differ, like Fivetran or something like that. Because it's open source and it's also declarative, and I'll kind of like walk through. And that's my biggest warning for Airbyte specifically, is that it's declarative, but it is YAML, so it's a little bit long in the tooth. So I'll walk through that really quick here. I just wanted to briefly show what we're going to walk through is an example of. We're going to change that to entire screen. Okay, so I'm going to walk through this really quick, and I have Grapple pulled up here. And as an example, what I was talking about earlier is we integrate data. We have probably 2 or 3 dozen internal APIs that we've written so far, at least. But then we're also working with a bunch of other external data sources. So what we're doing here is we're pulling in data from any number of SaaS offerings or even Postgres or Mongo. So it could be unstructured and we have like no idea what it is, right? And on this view here, you see we have about 30 or so sources, and traditionally, if you go through like an API integration process, what this would look like is writing a connector, writing a policy for doing retries and parallelization, and maybe some caching, making sure that you have authorization set up for this connector in a secure way. But one thing that we can do, thanks to Airbyte, is actually integrate a lot of that through a declarative YAML file. And I'll show as an example of what that looks like. That might be a little bit hard to read, but this is an example of a YAML file for Airbyte. And in this specific example, you can see here we're defining things like the different streams that are available, how to access those streams, but you can also encode information like here's how you do authorization. So because we can then declare all of that in a declarative way through YAML, we can just navigate through a source like HubSpot, for example. If I was maybe managing my CRM data in HubSpot, I can just click on that and then go through an OAuth flow, and just like that, oh no, authorization failed. Well, that's hilarious. But such is the case with demos. If that had succeeded, what we can do after that is we can walk through here and actually see the new connection being created in Airbyte. And you can kind of scroll through this list and see this happens to be the cloud-hosted version of Airbyte, but we could click through and see any of those connections being managed. So Airbyte's really interesting, like I mentioned, for the more transactional the more analytic workloads. So what changes when the hard part becomes easy? Because in many ways, API orchestration is easier than it's ever been before. We used to have all of these really reactive properties that we were thinking about. Authorization and authentication has been something that we've been thinking about a little bit differently recently. Maybe that's viewed as a solved problem. But there are a lot of other issues and a lot of other non-functional requirements that we have kind of viewed reactively. Like in many cases, something might not have, like we might not think through all of the requirements for something until it becomes a problem. Oh, our app is slow. I should implement a caching policy. Well, maybe not. It's a very reactive approach. So when a lot of these non-functional requirements are taken care of for us, we move from this very reactive state to a much more proactive approach. And some of the things that we might be thinking about in a more proactive approach are, how do we reuse our application? How do we reuse our APIs in the most efficient way possible? Can we expose these to agents in a different way? What are the monetization models that we can consider for our applications? In the most recent Postman report, 65% of organizations are monetizing or receiving revenue from their APIs, which is a tremendous number. I only expect that to grow. We can also think about things a little bit more out there, like autonomous APIs. All of these are a lot more proactive approaches to thinking about and our API program a little bit more holistically. So the biggest shift is we move from a reactive state to a proactive state. And there are a lot of different really interesting things that we can think about there. So the thing that I'll leave you with is, what is the next thing that's going to become easy? We've seen API orchestration become easy. That was a hard thing. I have some ideas, and I'm sure you do too. Thank you.